Okay, so now we want to talk about the second major class of sedimentary rocks, which are going to be the chemical precipitates. So if we go back to our master chart here, this is going to be the blue ones in this chart. So let's first talk about rock salt, rock gypsum, and limestone, and dolostone. So all of those are different kinds of rocks that are going to be precipitated whenever there is too much of it in ocean water. So it's like if you've got water and then you start putting sugar into it. At first, if you stir it up real good, you can't see any sugar. But if you put too much sugar into it, the water becomes saturated with the sugar and then it precipitates out. So the rock salt, the rock gypsum, the dolostone, and the limestone are all examples of those kinds of rocks. So what can cause the precipitation is going to be if the water evaporates. So as water begins to evaporate, the first kind of sedimentary rock that is going to precipitate out is going to be the limestone, and to a certain extent the dolostone. We can have an alternate explanation for dolostone, which I'm going to give you here in a moment. Okay, then as you continue to evaporate the water from the ocean, the next major type of rock that's going to form is the rock gypsum. So the mineral gypsum will begin to precipitate out of the water and make layers of rock gypsum. And then finally, as you continue to evaporate the water, the last mineral to precipitate out is going to be the halite. So you're going to have your rock salt. Okay, now one way of making dolostone though is once you've made your limestone, okay, and now let's say that the limestone is on a continent, then groundwater can carry in magnesium. And then that magnesium will start to replace the calcium in the limestone. So instead of having calcium carbonate, you're going to have a combination of calcium carbonate and magnesium carbonate. And so that is going to be dolostone. Okay, then what about bauxite? So where does bauxite come from? So when we talked about soils, we said that you would have a zone of leaching and eluviation. And so what would happen is that water would percolate through the soil and it would carry clay and aluminum from that layer down into another layer of the soil. So if that aluminum-rich sediment lithifies, then that's going to be bauxite. And then what we can do is we can dig up this bauxite and we can recover the aluminum from it. So most of the aluminum in your aluminum cans comes from this particular kind of sedimentary rock, bauxite. And then you've got travertine. So where does travertine come from? So this is going to come from caves, so that if you have a layer of limestone, so this is how you represent limestone, and then groundwater gets into it, it can start to dissolve away at the limestone, and it's going to leave holes in it. And at first, these holes are going to be filled with groundwater. Okay, but then what's going to happen is the ground table, the water table, is going to drop, and now this area is now going to be free of water. So it's not going to be underwater anymore. Okay, now what's going to happen though is, again, groundwater is going to drip into here, and as it drips in, it's going to start to re-precipitate the calcium carbonate. So at first, the groundwater dissolves the calcium carbonate and carries it away, leaving the hole, and then later the groundwater comes back in and it starts to drip in the cave, depositing recrystallized calcium carbonate, but we're not going to call it limestone. So it's going to be called travertine. And so you're going to have your stalactites up at the top, and then your stalagmites down there at the bottom. And so these are the kinds of rocks that you find inside of a cave. You can also find travertine at hot springs and geysers. So wherever you have water that has lots of calcium carbonate in it, and then it recrystallizes back into the mineral calcite, that's when you're going to have travertine. Okay, for those of you who just love chemistry, here's some chemistry for you. So this shows where calcite comes from. So you're going to have carbon dioxide in the air is going to mix with ocean water. Okay, then the carbon dioxide plus water is going to make carbonic acid. And the thing about acids, some acids, they give off hydrogen. And so the carbonic acid gives off a hydrogen, and then what you're left with is the bicarbonate. Then the bicarbonate gives off another hydrogen, and so now you're left with a carbonate ion. Now that carbonate ion can combine with calcium to make calcium carbonate, which is calcite. So it could be precipitated to the bottom, or the carbonate and the calcium can be taken in by a living organism, and then it can use that to make its shell with. And then when the organism dies, its shells accumulate on the bottom of the ocean, and then they can be cemented together to make limestone. So there's two different ways of making limestone. So if you're one of my students, don't freak out. So you're not going to need to know all of this chemistry for the exam, but you should know that carbon dioxide mixes with ocean water to make limestone. Now you might be wondering, what about the calcium? So where did the calcium come from? Well, if you look at the chemical compositions of a lot of the igneous rocks, you will find that they have calcium in them. And so as these igneous rocks weather, the calcium can get into the groundwater and it can be transported to the ocean. Also, if you've got limestone on the continent and it is eroded, then it breaks apart into carbonate and calcium, and those get into the water and then are transported to the ocean, where they can be put back together again to make new limestone. All right, so let's take a break, and when we come back, we'll talk about biochemical sedimentary rocks.